Hi guys, and welcome to Colorado State University's next STEM video. My name is Miss Stephanie, and today we're going to start part one of a two-part experiment dealing with shell-less eggs. Shell-less eggs? We can do that? Well, come along with me and I'll show you how to do part one, acid-base reactions. Now, before we get started, there's a couple things that you're going to need to grab from your kitchen. And don't worry, they're really simple to find. First, of course, you're going to need eggs. Regular, plain chicken eggs. I recommend doing this with about 3. You may want to do an extra one just in case something happens. So pull out 4 eggs from your mom's stash. Make sure she's okay with this first. And you can put the rest back in the fridge. On top of the eggs, you're also going to need white vinegar, jars. I use mason jars. You can use the taller ones. You just want to make sure that the jar can accommodate your egg or multiple eggs if you use the bigger ones. A spoon with a deep point so that you can move your eggs both in and out of your jars. We're going to want to take some measurements because we're doing science. So you'll need a ruler and either a piece of string or I found a piece of ribbon, easy to go around each egg. And then you always want a label, so make sure you grab some tape and a marker. And that should get us started for part one, shell-less eggs, acid-base reactions. All right, guys, now that you've got all your supplies together, first, let's talk about an egg. There's some simple parts that we all need to know about the egg. First is the shell, the hard outer part of the egg. But then what's on the inside? Well, you might have guessed yolk, the yellow part, or egg whites, the white part. There's a sac on the inside, that's the air sac. But did you know that between the egg and the innermost parts, between the shell and the innermost parts of the egg, there's a membrane. That membrane is a line of cells that help protect the inside parts of the egg from the outside world. And this type of membrane is semi-permeable, meaning that it can transport things between it. Keep that in mind as we talk about more in this experiment. So taking your first egg, you're going to want to get some measurements before you even start the shell-less process. Take your string and wrap it around the girth of your egg because we want to get how big the egg currently is. Once you find that point, on your ruler, you're going to want to use the centimeter size. That's the small numbers. And going from 1 forward, write down how wide of girth your egg is. Mine is 14 centimeters. So before I even get started, I'm going to take my label and I'm going to write 14 cm, just like that. Now take your label and label one of your jars. That's the same jar that the egg you just used will go into. This is so you can keep track of all your measurements as well as your eggs, because you're going to want to find out if anything changed in the egg after the experiment's completed. Go ahead and stick that egg in the jar and then take the measurements of your other 3 eggs. All right, now that you have measurements of all of your eggs, this is the easy part. In order to start a chemical reaction and start dissolving your eggshell, all you need is vinegar. Now vinegar is an acid. Acids have corrosive properties and they usually don't taste very good. They're sour or bitter. Another type of acid would be like orange juice, but we're not going to use that today. Take your vinegar and fully submerge your egg. You don't have to fill it all the way to the top. Just make sure that your whole egg is covered. Perfect. Now vinegar is pretty strong smelling, so you may want to put a lid on your jar if you're going to keep it in the kitchen or even in the refrigerator, because I didn't tell you guys, but this has to sit for 7 days. I know, a really long time, but I promise the end result is worth it. It's going to be fun. So what's happening? Well, right now, I don't know if you can see it, but see those little bubbles that are forming around the egg? That's our start of a chemical reaction. What's happening is our acid, vinegar, is actually breaking down our shell, which is more basic. Base just means that it has a pH of above 7, where an acid has a pH of below 7. And the chemical reaction is causing the shell, which is calcium carbonate, to break down into calcium ions and carbon dioxide. The bubbles are carbon dioxide. Now let this set for a little while and come back and check it in a couple hours and you'll see lots of bubbles. And that's just CO2, carbon dioxide, being released as we form a chemical reaction. Now, a couple instructions for the week. After this sits for 24 hours, you're going to want to carefully pour the vinegar down the drain, take your spoon and pull the egg out, wash it gently under the faucet, and then put it back in your jar, and you guessed it, fill it up with vinegar again. After you do this once, you don't have to do anything else. You'll leave the egg sitting in the vinegar in a safe spot for the next 6 days. Once the time has passed, you should see a fully shellless egg, just like this guy. See, he doesn't have a shell anymore, just the membrane. And you can still see CO2 bubbles forming around the egg. Now, I know my egg's kind of hard to see, but give your egg 7 days and you'll be good to go. Now, that's all you need to do to make your shellless eggs. Now, like I said, do that with your other 3 eggs, so you'll have 4 jars going, because you're going to want at least 4 eggs to complete experiment part 2, osmosis. Now, when your eggs are finished, before you start part 2, don't forget to take them out of the vinegar, put them on a paper towel, and measure them again. And tell me what changes you see. Did the eggs get bigger, smaller, or stay the same? That's science. Thanks for stimming with me, and we'll see you soon for part 2, shellless eggs osmosis. Bye.